I'll give you the windmill construction. This project is your first freedom of design. So before you grab any Allen wrench, any bolt, any gear, any gusset, or any other piece of material, you get on that engineer sketchbook and you sketch out what your windmill will look like. I need to sign off on it before you start building. You guys got it? I figured so. Got it on that side? Okay. Once you get the windmill done and I check it off, the last project you will get before we start doing our survivor challenge, you get to do the pool tour. Yeah, that's a fun one. I like that too. This is the 8th grade robotics class. These kids will be with me for the entire year. The first half of the year we are learning basic gear mechanisms, how they work, when we should use a gear setup, how to put it together actually. And in this last half of the year they will start to automate the buildings that they are doing now. So we'll do an automated assembly line, we'll get into some automating of robots, we'll do a final project is going to be a carnival assembly where they do carnival rides.
Before we started making the windmill, we had to do a lot of other stuff, so we basically know what we were doing first. And then after we got through all that, we started. We first had to like sketch out what we were gonna make, and we're basically making a bevel gear, and it's gonna go down to another bevel gear for our output, and that's basically what we're building now. We were making a windmill, and the input. It's gonna be right here. So we're gonna spin the leather foot right here, and it's gonna turn to windmill. And then down here, there's gonna be an output where, like, something would get energy from.
What we're doing right now is kind of a chain of events, if you could say. Like, we do one project first. We have multiple assignments we're supposed to do one after the other. This right here is like 8th or 9th one we've done.
It's a car you pull, and we got bevel gears that goes to the front, and then it's gonna have like when it moves, it's gonna have a working job come off of it.
I'm actually working on the universal joint, which means like basically it moves from this way to this way.
We have to learn all these simple gear builds before we get into some of the more complex ones. So we have to learn like the chain drive, universal joint, the lead screw like I'm doing here. To do it like all those, so we learn the basic gears before we actually do like the more complex stuff.
3/4 of what we do comes directly from the project Lead the Way curriculum documents. The way they have it set up, it is a very user-friendly curriculum to follow. It gives the kids a very good relationship between the academic and the real world. In fact, you could even go so far to say this is industry-specific curriculum. It's not pedagogy, it's not for standardized tests, it's not for accountability. It is to get these kids introduced and get them almost cultivated to think about technology careers.
It's a project where robotics can be used in everyday life, and the teachers teach you how to build stuff so that if you want to be an engineer, you already have the smarts to build.
If we were ever wanted to be an engineer or anything, we would have more experience than somebody that didn't have this class.
We had the film crew from Project Lead the Way. Their director of communications contacted us a couple weeks ago and asked if we would open up our classroom to them. And of course, we love the publicity. So they came down and they were doing the same thing you guys are doing. They were watching the kids in action. And as you can see back there, I'm really not needed much in the classroom. I'm more a facilitator than I'm a teacher. That's 80% of what I do is walking with the kids, talking to them, pointing out some build errors, some of the concepts behind what they're doing. So it's very little teacher talk going on. It's the whole engineering approach. You come up with a basic idea, you design and build what your idea is, then you start to test it. And there's not an engineer out there from mechanical to industrial to a computer engineer who does not have to redesign numerous times. So all we're doing is, again, exposing them to an industry real situation where you've done a build, it does not work the way you need to, then find out what's wrong and rebuild it. My job is to, when they just are totally stuck and they can't see the error, they can't see the possible rebuild, I give them a little bit of guidance as to where the problem might lie and possibly how they could rebuild it.
This class is supposed to be like a more figured out yourself type thing, so Well, we have like pictures up there we look at, and so yeah. Or we can maybe just look it up on our computer.
You said the 2 spacers. Which spacers are you talking about? Point at it. Collar. Okay, that's all right. You knew what it was. So you need, how many collars are you gonna have? 2. Good. At least 2, maybe a couple more, but 2 for sure. Okay. What does it look like?
I don't know what kind. It's like that kind of gear we use on the Windmill.
It is, but now come back and look at the rack real quick.
In this class, though, you get to make stuff, you get to design on these programs.
It's all
great.
you.
And it's fun to use your hands to build things and be creative.